software. Okay, so completely you can assume this is a software part. If you are having any questions, please let me know. So IoT and cloud computing. So are you people aware about? So is now my voice is clear? Gopi, are you able to hear me? Someone please confirm that screen is visible and voice is clear. Is my voice clear? Yeah, thank you. So Gopi, please check your side or increase the volume in your headset or your laptop. Okay. So we will proceed with the presentation and understand the subject, how IoT or cloud computing will work in our embedded systems and IoT. Okay. So are you aware about the terminology about cloud computing? If you are aware about the cloud computing, so it is well and good. So if you are not aware, so how IoT is applicable for cloud computing, let us understand and understand the basics of cloud computing also. So what is cloud computing? So cloud computing is an array of networked computers that allow you to offload processing tasks or storage from your embedded systems. So as I have told you, okay, in the previous example, okay, we have installed 4 Raspberry Pi boards in one fish pond. All these are connected to a single network. And this network is connected to a AWS cloud. So this interface coding is built on Python programming language. As we have learned Python programming language and we are aware about installation of Python also. As the sensor data coming from the Raspberry Pi or taking the sensor data from the sensors like humidity sensor, temperature sensor, moisture sensor, sedimentation sensor, and dissolved oxygen sensor, pH sensor. So all these sensors are of 4 sets. For 1 acre of pond, we have installed 4 sets of Raspberry Pis and 4 sets of sensors. So all these sensors are sending the data to the Raspberry Pi. And to receive the data to a centralized location, we have connected a AWS cloud. So that is what the practical example is. So what is the cloud computing? So certain devices or embedded devices or our computers connected on the network and offloaded. Offloaded means there is a load sharing. And one more thing, when the sensors are sending the data from one set of Raspberry Pi to another set of Raspberry Pi, all these are connected on a single network. Okay. So if consider node A, node B, node C, node D. Okay. If node C, Raspberry Pi has gone down, okay, we are unable to get node C sensor values. At that instance of time, we will get to know this node is not communicating with the other 3 nodes. Then immediately we can take an action to repair or to arrange some alternate in that node C. This is how the cloud computing will help us. Like handshaking of application or handshaking of data receive or transfer. So as per the textbook definition or internet definition, what is cloud computing? Cloud computing is a array of network. So all these devices are connected in a network that allow you to offload. Offload means data sharing. Process the tasks. What are the tasks that our microcontroller boards does? They process some amount of data and do some input and publish some output. and we have a small amount of storage on the microcontrollers, hardly in MBs. Whereas in Raspberry Pi, we can have huge number of storage, like 128 GB or even 256 GB or even 1 TB also we can install using a flash SD card drive. Okay, or else we can connect using USB. We can connect external hard disk also, as Raspberry Pi is a Linux operating system. So we can connect up to 10 TB, 20 TB also. But on a remote site, to monitor the storage or to replace the storage is very tough. So what we do, we receive the data into the microcontroller storage, that is Raspberry Pi storage, which is having 32 GB, 64 GB or 128 GB. Whatever the raw data we have, that raw data we are sending over the internet to the cloud. The cloud is nothing but we have some cloud providers like Google Cloud Platform or Amazon AWS or Microsoft Azure. Next is Linode, and there are other private clouds also. Okay, in this way we are using the application in IoT as a cloud computing. Is this example clear, everyone, and understanding the definition of the cloud computing? Dear participants, please reply on the chat. If you are understood, we'll proceed further. Excuse. If you have any question, we'll hold it and we'll proceed. We'll understand and we'll proceed. Okay. Thank you, Vinay and Alluri. Yeah. IoT and cloud. So IoT applications will need support from a reliable, fast, and agile computing platform. Okay. IoT devices can overcome lack of software, firmware, memory storage, hardware, data processing capabilities through cloud computing. So as we know, if we interface instead of Raspberry Pi, okay, so Raspberry Pi is a cost-effective. If we go for a Node MCU example, the same thing, whatever the application I have done using Raspberry Pi, we can do the same thing with Node MCU also. But Node MCU does not have any operating system, and Node MCU has very less amount of process. Okay, and it's having less amount of storage. So what we do is we just collect the data, we send the data to the cloud, and the cloud can compute, and cloud can perform filtration of data, and cloud can perform analysis of data, and cloud can publish the data in various forms as a report to the users. So where we don't want to invest more on the hardware and we don't rely more on the hardware, okay, we can trust on the cloud. That's how IoT works. IoT is nothing but most of the part we work on the internet. So cloud is nothing but it is a remote compute, remote storage, remote data process, and remote hardware. Everything is on the remote. We utilize that as a resource in our application. What is our application? Water quality management for system for fish ponds or aqua cultivation. So there are several models of cloud computing. Those are software as a service, first one. Next one is platform as a service, and third one is infrastructure as a service. In detail, we'll understand what these service models are. Clear so far? Raja, yes sir. Next. Generally speaking, cloud computing can be a thought of has anything that involves delivering hosted service over the internet. As we have discussed, the cloud computing is a hosted service over internet. So we have web servers, right? GoDaddy, BigRock, and other web servers. Okay, so someone from the software or someone who is learning web technologies, they might be knowing this concept. Okay, so all these are working on the cloud, web servers, and we have our college login portals, JNTU results portals, or our university result portals. All these are published only on the internet. So they are posted. Posted means they are installed. Example. In our terminology, they are installed on the internet. Internet is nothing but it is a remote server. Clear? So what it provides? Cloud computing. Cloud computing provides shared services as a opposed to local servers or storage resources. So if I want 256 GB of RAM, okay, and 64 cores of process and 1 TB of storage. Okay, like this, we will request to the cloud service provider. What will it? 256 GB RAM, and these all are for compute. 64 cores CPU for processing. Next is 1 TB data store for storage. Okay, so this request we will give it to the cloud partner or cloud provider. So I have one site in Bhimavaram for aqua cultivation. I have another site in Chennai for aqua cultivation. I have another site in Vizag for aqua cultivation. I have another site in Amalapuram aqua cultivation. Okay, so each and every location has n number of devices, and I have n number of locations. To communicate all these devices to one storage, one compute, okay, I need to map it to my cloud. So here is my location, Hyderabad. And here is my site 1, Bhimavaram. Here is my site 2. Here is my site 3. Vizag. Here is my site 4. Chennai. Okay. So all these are having 4 nodes, 6 nodes, 8 nodes, and 10 nodes. All these nodes are nothing but our sensor collecting nodes. Okay. Whatever the 4, 6, 8, 10 we are speaking, those are Raspberry Pi, connected to a pH sensor, connected to a dissolved oxygen sensor, connected to a sedimentation sensor, connected to a temperature sensor, connected to a humidity sensor. So this complete is one node. Like this, in Bhimavaram, we have 4 nodes. In Kakinada, we have 6 nodes. And in Vizag, we have 8 nodes. In Chennai, we have 10 nodes. All these nodes are not interconnected. All these nodes are connecting to my server. And server is talking to these compute resources. Okay. So what is the compute resources of my Raspberry Pi? It has 4 GB RAM. Okay. And 2.4 gigahertz frequency of 2 core process and 128 GB of SD card. All this together is one node specifications. So will it be sufficient in a long run to maintain the data for 1 year or for 3 years or 5 years on this one node is possible? It is hardly possible for 3 months or 6 months maximum, but not for 1 year, but not for 3 years, but not for 5 years. So what we'll do? We'll connect all these nodes over internet to a server cloud node. So how this communication happens enables access to information from most web-enabled hardware. So we will have some web-enabled sockets, web-enabled applications on the each node. So this will talk to my server directly. Allows for cost saving, reduced facility, hardware and software investments, and support. So if the node is not responding, okay, we will get a notification on our server that this node is not transmitting data since 4 hours, 6 hours, 48 hours, or even 64 hours. Then what we will do? If it is very critical, we'll try to replace the complete node. If it is repairable, we will try to diagnose which sensor is not working, where is the troubleshoot, what is the battery, what is the network issue. All this we'll try to diagnose. And that is what called as support. So each node will cost some amount. Okay. So for fish cultivation, for aqua ponds, this investments becomes very high. So they want to maintain it for 3 years minimum and 5 years maximum. Not even for 1 year. Got it, everyone? Dear participants, you are able to understand what I am speaking? Next, as we have discussed, there are 3 models in cloud computing. So what are those? Software as a service, platform as a service, infrastructure as a service. So coming to detail, service models: software as a service, platform as a service, infrastructure as a service. So clearly telling, infrastructure is nothing but hardware. Platform is nothing but compute, storage, resources. Okay. Next, application is nothing but data analysis. Example, MATLAB, AI, ML nowadays. Previously, we use, most of the times we use MATLAB, software or application. Clear? So taking reference to this, we'll proceed further. Is this clear? What are the service models and what service models contains? You are intelligent, so oh, this will not stick here, so I need to erase it. Better. Software. So coming to the service models, the first one is infrastructure as a service. Infrastructure we have understood like hardware. So infrastructure as a service, IaaS, it's abbreviation. Okay, a service model that involves outsourcing the basic infrastructure used to support operations, including storage, hardware, servers, and networking components. Okay, so how it looks like, I'll show you. So these are the servers. Okay. So this is one HP server and this is one Dell server. So what is the frequency? It is having 2 gigahertz. How many cores? 56 CPUs. Okay. So you are able to see, right? Everyone, screen is visible. So this as a infrastructure or a service I am explaining you. Infrastructure. You are able to see everyone? Dear participants, please. Yes. So this is one Dell server and this is one HP server. So these two servers are made to a infrastructure. So this has compute resources of 56 CPUs. Okay. And RAM of 1 TB. Okay. And storage of 16 TB. Here you can see. In the small letters. Here it has storage of 16 TB. And the other server is HP server, which has compute of 128 CPUs. And RAM of 512 GB. And storage of 7 TB or 6 point something. Okay. So this has infrastructure. Completely, we have built a one data center. So data center has how many nodes? 2 nodes, 2 servers. Okay. So similar way, infrastructure has a service model that involves outsourcing the basic infrastructure used to support operations, including storage. Storage we have seen, hardware, servers, and networking components. So we have connected to network also. The service provider owns the infrastructure equipment. So those who are providing this infrastructure as a service, they will have the ownership of their server equipment and is responsible for housing. They will only take care. The owner will only take care about installation, running, maintenance. And the customer typically pays on a use basis. So what we need to do? We want to rent it or we want to lease it. Lease is nothing but long term. Rent it is nothing but we can take rental on every monthly basis or even daily basis. Clear? Infrastructure as a service. Someone please confirm. Yes, sir. Next, platform as a service. Platform as a service will provide the operating system. The service model that involves outsourcing the basic infrastructure and platform, Windows or Linux. So on the servers, we have the physical servers. Those physical servers need to be installed with operating systems. So if we rent only infrastructure, okay, the user has to take care about operating system and application. Platform as a service facilitates deploying application without the cost and complexity of buying and managing the underlying hardware and software where the applications are hosted. So if we are renting a platform as a service, that will involve hardware and software applications hosted on the platform as a service. We will get as a package. And the customer uses their own application. They will give you us Windows or Linux. Whatever we tell them we want 64 core CPUs, 256 GB of RAM, and 1 TB of storage installed with Linux operating system. They will give us with the Linux operating system. So user will take care, or the owner who wants to rent it, who wants to lease the platform, they will install their own application. Clear? There are some service level agreements between cloud service provider and user. You are able to understand this, right? Yes, sir. Thank you. Next, software as a service, also referred to as software on demand. This service model involves outsourcing the infrastructure, platform, and software application. This covers all the three. They will have infrastructure, they will have operating system. On that operating system, they will install the application and give it for rent or lease. Typically, these services are available to the customer for a fee, pay as you go, and as a no charge model. There are some free service, software as a service, like open source thing. And there are software as a services which has application also. If you go to AWS or Google Cloud or Azure, directly you want to go for infrastructure, you want to go for a platform, you want to go to software. Whatever the model you want to go, you can check out. And you need to select the filters, which operating system you want to install, which application you want to install. And the service provider takes our request and he will need some amount of time, like 4 hours, 6 hours, or 8 hours to set up that and give it to you for access. Once the software as application comes into user hand, customer or the user will use the application over the internet. Nowadays, we can run MATLAB in internet also. If we have our university email ID. If we have our corporate email ID. Corporate email ID means chaitanya@qualcomm.com. Chaitanya@intel.com, Chaitanya@amd.com, or Chaitanya@IIDT-APSCHE.in, academics or corporate. So they will check based on our domain whether this email ID is eligible to fetch MATLAB license or not. Yes, he is eligible. She is eligible. Then they will give you the access. Else, they will give you the 15 days or 30 days trial period. As your email is, as your domain email is not registered for MATLAB licenses, you are only having 15 days or 30 days of license period, trial license. If you want to renew, please pay this amount. So that as software as a service and cloud computing. Hope everyone understood this much. Sunil, thank you. Nadapalli, thank you. Raja, thank you. Vinay, thank you. Good. Participants are understanding the concept. So first, illustrating this example, infrastructure. Infrastructure consists of storage, compute, network, and platform consists of operating system, which are working on object storage, runtime, database. So as a platform, how database will appear? We know this thing. Question. So if we install Oracle Linux, Oracle OS Linux will have default database application in the operating system itself. If we install Microsoft 2022 or 2023 server, Microsoft server, that will have MySQL database. That is platform. So as a platform, we got database operating system. And as an application, we will use for monitoring, for content development, or for communication, or for finance activities. What are the financial applications we have? SAP. Okay. Or Tally. The basic one is the Tally, usually we use. And the end user who wants to access them, they will be accessing using mobile phones, tablets, laptops, desktops, or even servers. This image is clear for everyone, illustrating how cloud computing will work. We can see that this compute is everywhere in the remote, but it is situated on the planet somewhere, but it is connected over internet. Clear, everyone? Right. So, as we know that if we are talking about anything, we need to check about characteristics. I am buying an Apple iPhone 15. What are its characteristics? What are its features? Similar way, if I am going for some cloud service provider, example Google Cloud, or Amazon Cloud, or Azure Cloud, or Linode Cloud, or Entity Data Cloud, or IBM Cloud, any cloud. So what are its characteristics? What are its features? On-demand self-service. The concept called on-demand self-service. So you need a support of cloud provider. Okay. When you need, you will raise a ticket. Clear? Next is broad network access. Connectivity options. So I have leased line options, with 1 gig speed and 100 megahertz speed, 50 megahertz speed, and 10 Mbps speed. So these are leased line options. And apart from that, I have broadband options also. Broadband options which are having 100 Mbps, 70 Mbps, 50 Mbps, and 10 Mbps. So leased line will give you clean internet and broadband will give you shared internet. From one leased line, we can split n number of broadband lines. This is how our network works in our cities. So which network to choose is the connectivity option. Next is resource pooling. Resource pooling means you want to access the compute resources or storage resources in a remote connectivity using command line or using GUI. If you want to use connect GUI, you will be using VNC or you will be using XRDP. If you want to connect by using terminal, you will use command prompt or you will be using SSH putty. This is how resource pooling happens. Clear? Characteristics. Next is deployment models. Deployment models are coming with private cloud. Private cloud is nothing but I have a company called Blackbucks. Blackbucks has its own data center, which is having 150 servers and 1000 petabytes of storage and 64,000 cores compute resources. This is my data center specifications with compute resources. This is my private cloud. So if I want to give anyone access, I can give them as a VM basis, as a server basis, as a infrastructure, as a platform, as a software. Any kind of thing, I can do it. Private cloud. And coming to public cloud. Community cloud, hybrid cloud. So in detail, we'll understand each and every. So how we are enabling the technologies. So initially, we used to have RFID communication to identify and track the data of things. Sensors to collect and process the data to detect the changes in the physical status of things. So consider an application, okay? RFID attendance, sensor-based attendance, smart tech attendance, nanotech attendance. So how we are going to relate it to this application? Attendance monitoring system. RFID means you have a access card. Sensors, face recognition or thumb recognition. Next is smart tech to enhance the power of the network by devolving processing capabilities to different part of the network. That it means you have a application in your laptop. If you are a software engineer, okay, you have started working at 9 a.m. and your logout time is 6 p.m. and it will calculate all your screen time and your screen activities. Based on that, your working hours will be reported to your manager 7.5 hours. That is smart technique. Next is nanotech. As we have seen, in the technologies, when we go for some certification courses or when we go for GRE, IELTS, TOEFL, so they will be aligned around you cameras for tamper proof. So that is nanotech. So all these are coming with attendance monitoring system. So for every generation, for every change in the technology, we are overcoming the rectifications. RFID, okay, it is active or passive tag. Next is sensor, face recognition or thumb recognition, fingerprint. Next is your screen time based attendance, your login time. Next is based on CC cameras and your screen time. You are able to relate it? Yes or no? Whether you are able to understand this slide or not, how the technologies are enabled. Clear? Followed everyone? Understood? Sanjay, yes. Sunil, yes. Chinnu, no. Who is that? Who is Chinnu? And what didn't you understand? Please, can you post it on the chat window? So I'm explaining it very clearly and with an example in our real life application. So try to relate it with from smart tech. So RFID system, we have our ID card for attendance system. Okay. When we go to office, if we tap our ID card, we will give our attendance system. When we are coming out of from office, if we tap again, we will get a logout time. Clear? Using RFID. Chinu. Next is sensor. Sensor is nothing but face recognition or fingerprint recognition. So when you are going to office, you have given your fingerprint for login. When you are log out from the office, another time you are giving fingerprint. That is logout. And next thing is you don't have RFID, you don't have face, you don't have thumb impression. And the ultimate thing is, very smart thing is your laptop or your desktop, your login screen time. You are logging to your laptop to work in the morning 9 a.m. and your number of working hours are 8 hours. Okay. Leaving the break half an hour or 40 minutes for lunch. It will record all your screen time and your work activities and it will report to your manager how many hours you are working on the laptop. Next thing is nanotechnology. So in real life applications, when you go for some certification exams like SAP, Red Hat, or IELTS, TOEFL, GRE, okay, they will be surrounded by CCTV cameras and your laptop camera also and your desktop camera also. Okay, same way they enabling technology as advancements. Got it, Sinu? Thank you. Applications of IoT. So how do we apply IoT in these kind of applications? So everyone has to give an example. So everyone has to give me an example for education as an IoT application. So imagine or think beyond the subject as we are students in education system, how IoT will be applicable for us. Raja, it is retail. Okay. Home appliance is retail. In education, means as a research, as a development. Yeah, automated attendance recording system. Correct, Chinu. In education system, every students not to pay condonation fees. Okay. They need to be attentive to the class every day. So you have an school application or you have an school Android app or iOS app which will report to your parents out of 30 working days. Okay. 20 days your son has come to school or your daughter has come to school. So at last this message will come to our house. Zoom is not a IoT application, it is a cloud application. Next is on food. How we will apply on food IoT application. Online delivery, Chino, it is logistics. Online logistics, online delivery. What about food? Smart stove is a retail. Okay, if you have an electric stove. Okay, so you have placed 2 cups of rice in the rice cooker in the morning and you went outside and you want to turn on the rice cooker. Okay, by the time you reach house, the rice is cooked. Was it? But it is a retail application. Vasu, it's a retail application. Okay. I am asking about food. Food. Yes, example, smart refrigerator is also retail application, but as a food grade, okay, I can explain you or convert in this way, smart refrigerator. So as nowadays the smart refrigerators are coming for different chambers for water bottles or they are having inbuilt water purifier also nowadays, very costly fridge. Okay, and that has smart IoT application also. So based on the food grade, if it is ice cream, we can control the cooling, and if it is normal food like pulses, like tofu dal, okay, that we are putting in another channel, and if it is fruits and vegetables, we are putting in another channel. Okay, so I have an example for food grade. Okay, so in India, Washington apples are very famous. The red apples, which are imported from Washington. Okay, those are grazed or those are grown in our Kashmir only. Okay, but even the original apples are imported from Washington. But we have a seed plant in Kashmir. So to transport these apples, it takes lot many days of time to reach different destinations of country or states. So to estimate what is the harvest period, and how many days it can be alive. The fruit. We know what is the freshness of the fruit. To do this, I have done an experiment. So using laser, okay, I have monitored or the age of the fruit when it is harvested and how long it is fresh and when it has to be consumed after harvest. This is based on the IoT application. And we have made a label for each and every apple. It is harvested on this day and this has to be consumed in these many days. Right? As it is a perishable. Got it, everyone? The example of food, IoT application. And we don't display directly on the fruit. We display it on the batch-wise boxes. So we ship as a vendor. Vendor ships apples in a box of 100 or 50. So all are harvested on a same day. So we will put a QR code or a barcode. So that QR code or barcode is scanned by the shopkeeper, like Ratnadeep, Vijeta, or more supermarket. They will get to know that this food is resellable for this many days in the store. Else, this has to be removed. Got it, everyone? Next is pharmaceuticals. So, pharmaceuticals, how they will do for the drug calculations. So, they have more critical, more experimental way of chemicals, not to touch with hand, not to smell, not to enter into the premises. At that instance of time, they will be using IoT. So they want to mix some poisonous gases. They want to mix some chemicals. Okay. So they will use sensors and they will read the readings and how much proportion they want to mix it. Based on that, they will get in the application of pharmaceuticals. And as our friend said, logistics, online delivery. Next, retail is smart electric gas stove or smart automated AC. Next is management. So has IoT management. So nowadays I use in my home for the management purpose. So when I want to clean my floor, I allow my vacuum cleaner to run on the floor. Okay. For every 4 hours, 3 hours. That I have set in my mobile phone. And when there is a temperature of more than 32 degrees in the room, automatically the AC turns on. Okay. And all these are smart power management with plug-in IoT sockets, power sockets. So I am not directly talking to the AC or the vacuum robot. I am directly talking to the power source. Once after power source is on, then I am switching to that application to control the application. Unless until that, I am reading the values from the environment, like temperature, and using the humidity, and use by seeing the dust on the floor. And looking at my CC camera, my younger child, whether he is doing some critical tasks or not, and how to avoid this. Even this all I am monitoring my mobile phone nowadays. Okay, even my wife is working, so we all are very strict in my roles. My elder son will go to school in the morning at 8 a.m. and he'll come at 5:30 p.m. and he'll fresh up for some time. He will eat small snacks and he does his homework and he play with his younger brother. And whether they two get hit together, I need to check in my CC camera. Okay, this is how I manage my house. So this is all about the real-time IoT applications. Clear so far, everyone? Yeah. So even when he wants to take print out, we have two printers in the house. One is color printer and one is Xerox printer. Okay. So for his activities or for his notes, he uses Xerox printer. And when he wants to take color prints, he will be opening my app in my mobile phone and he will be opening the Google Chrome. He'll search with voice Siri or Alexa and he will open that image and he will adjust the fit image to the paper size and he'll take printout. So this much is the management or activity in routine we have using IoT applications. And all these are connected in an Wi-Fi mesh network. I have built a Wi-Fi mesh network in my house using Wi-Fi routers. So wherever you go, there is no network region. Everywhere you will get the internet. Even though we don't have phone signal, we can call the mobile numbers using Wi-Fi calling. This much advancement we have come with IoT. Got everyone? Hope this is my real life example. Got it, everyone? Understood? Yes. Very interesting, right? Yeah. Even my mother and father, they are telling you are very advanced living in your technology. So earlier, when it is summer, we used to have in front of our house, we used to have a big nilagiri tree or a big neem tree and big tamarind tree. Under these trees, we used to play. And nowadays, you are growing your sons in an AC. They will give me an example of my past life and present life. So this much advancement technology we have nowadays. Okay, better try to adapt the older traditional life, not to the modern life. Okay, learn the modern life, but adapt to the traditional life. It is good for health and well-being. Correct, right? Yes. Next is as a management. Okay, so data management, as I have told you. Okay, so waste management. So when we have a dustbin in our house, we call the watchman guardian, okay, who sits below the floor. Okay, we call them to pick up the dustbin. Next is urban planning. So in our township, we will ask them to plan about street lights. Every weekend they will be checking in the morning. 6 o'clock they will start and they will check every electrical pole and lining, wires and electrical bulbs are blinking or not. Next is production. Production means, so if there is a traffic jam at the main gate, okay, the cars entering, the school buses entering, the office cabs entering. So everything has a parking space in the launch. So we will arrange one particular pickup points. So to reach the pickup points, we have all the rainproof. Okay, so all the rainproof road or the path, like footpath. So everyone can reach at the pickup point without getting wet. And in that pickup point, buses or cabs or any cabs can pick up. So they are not allowed directly to the front door. Whether it is an ambulance, then only they will allow the security people. Like that, they are managing the urban planning and production management. Next is logistics. As you have told, the goods are picked up from the warehouse and they are shipped with different transportation, roadways, railways, waterways, and airways. And we have labels on the products which are shipped from the warehouse to the destination. So they are having some codes. Next, retail. So in retail, we have, if you go to Ratnadeep or if you go to some shopping mall, so they will be having QR code or barcode for electricals. And if you go for some branded Decathlon or shopper stops or any pantaloons, so they will be having electronic tags also, RFID tags. So when you cross the bar or the electrical security check, okay, they will be blinking if the bill is not paid for this product. If the bill is paid, the tag gets deactivated. Okay, this is how we apply in the real retail. Next is pharmaceuticals. So they have intelligent tags for drugs. Next is drug usage tracking. So we have developed a ECG monitoring system. ECG monitoring system, what it does, it will take the graph of our heart rate. So based on that, how much dose of BP tablet you need to take. And next thing is on the hip part, just above the back, okay, we insert a device for sugar level monitoring. And based on that, it will inject insulin. This is based on the healthcare of pharmaceuticals. And nowadays, everyone using smartwatches. And if there is any criticality, it will report the heart rate. And it will report the pulse. And it will notify to the emergency number which you have saved in your mobile phone. Yeah, I have tested in Apple these things. They are working properly. Next is food. I have told you related to the Washington apples. So based on the food control quality to avoid expiration of perishable goods for good health monitoring system. Okay. So Internet of Things, mobile learning, smart objects, virtual worlds, gamings. All these are connected on Internet of Things. So as a school administration, we are using attendance management system and our smart voting system. Okay. Next is foreign language learning, information management system, media. All these are communicating nowadays on IoT. Smart things timeline. Okay. So in 2008, we have a job work. That is one of the device which used to communicate with IoT. Next is Fitbit, dual band, like fitness. Next is in 2013, we have Google Nest. That is smart Wi-Fi access point. And next is smart TVs, smart cameras, Google glasses, and spotter devices. Like spotter devices means they are having security. Next is Apple iPhone watches or many more smartwatches has come into picture after 2012. Okay. Next is current trend, personal assistant robots. Okay. Very much. So even some restaurants, there are 4 or 5 restaurants in Hyderabad. They are serving using robots instead of manpower. Okay. And there are robo kitchens also. I saw it somewhere in the news. Okay. Challenges and issues. So everything, whatever the technology we develop, that technology has some pros and cons and limitations and challenges. Okay. society, people, security, privacy. Okay. So as we know, Robo, Chippy, they have developed, but they don't have any feelings. But it gets hurt to the people. It can not be deployed in the defense. Okay. As it is neural schema, it has to have its own sense. And as we have seen in Chote Mia or Bade Mia movie also. Okay. So that Malayalam hero, he will develop cloning concept robots. But the officials deny it. They does not allow, but they should have their own self-respect to defend a war or a situation. So this can be done only by humans. So as the IoT, internets, robots, everything is enabled, we are restricting the technology for well-being of ourselves. This is what the challenges and issues we face. Okay. Hope you are understanding. IoT related to cloud and next back to IoT applications. Yes. So hype cycle of IoT. So when I was studying my engineering, there was no scope of IoT. We have learned and we have developed applications using Atmega 328. And hardly we have a high level board of ARM LPC 2148, I remember, or 1768. And nowadays we have ARM application series A9 boards or even A11 boards also, which are used in our mobile phone processors. That's how it has developed the productivity cycle after 10 years. So I have completed my MTech in 2014. Okay. And the IoT came into the market in 2008. Okay. And it has given a drastic change. Like Siri, Alexa, and nowadays people are talking less to the other friends. So in traditional days, okay, we nearby houses or neighbors used to communicate by sitting in the parks. And nowadays, video call. This is how the advancement of internet things. So as the technology improved, it made our life simple, but we are losing the human touch, humanitarian. Yeah. So technology roadmap. This is also one of the analysis graph we have done. Okay. Future of IoT. IoT landscape. These all are the companies they have built based on the platform, application, and building blocks. So when I joined Blackbucks internship, there was a company called in Banjara Hills, Hug Innovations. Yeah, I can show you that. So this was the first gesture control watch, which was developed by Blackbucks in collaboration with Hug Innovations. This has been launched by Rapid Preet in Gachibowli Stadium. So this is gesture control. So based on the gestures, what are the operations we do that can be controlled. Okay. So we need to have the interface with our mobile phone and we need to have the interface with our smart TVs. Okay. So if we want to change the channel or if we want to change the icons, okay. So what we need to do? We need to do top, left, right. That's it. And we have adjusted the wrist frequency to this watch. This watch has 9-axis gyroscopic sensor. 9-axis gyro sensor. Okay. 9x is IMU. Okay. So this is how the main component we have used. Inertial module. So as we know, inertial module, how it will work. 3D accelerometer, 3D gyroscopic with I2C and 3D magnetometer. So the acceleration is nothing but how fast we do. And magnetometer is nothing but it is based on the position. Next is 3D gyroscopic means direction. So try to have this kind of experience in future. Okay. Everything. The future of IoT. So this is a complete slide. So how it is applicable in our daily life, air pollution, forest fire detection, wine quality enhancing. Okay. Next is off spear care, sportsman care, structural health, smartphone detection, perimeter access control. And next is radiation levels, water quality, quality of shipment condition, golf course, smart parking, waste management, item location, okay, vehicle auto diagnosis, water leakage, noise urban maps, intelligent shopping, smart lighting, smart roads. So I can see I have given an R&D research for one of the Germany shopping mall, okay, where we got a conference. So using BLE. So usually all the items in a shopping mall arranged in a rack wise, row wise, or department wise. If we go for some shopping mall like Spencer's or Ratnadeep, we have at the first we have perishable goods like fruits, vegetables, milk products or dairy products or ice creams or anything. Okay. Next thing we have groceries. Next thing we have cosmetics. Next thing we have uh, utilities like washroom cleaners or anything like that. Next thing we have clothing. Next thing we have plastic. So to detect all these, okay, as per the rack in a mobile phone, okay, to navigate easily, we have developed an application and we have inserted BLE beacons. So I'll show you the sensors. So this is what we have used. So BLE beacons. So BLE beacons are used for indoor shopping. So these are NRF. So near field communication. NRF means near field communication. So nowadays they are using NFC, near field communication, NRF. So same way we have used for indoor shopping. So each and every rack we used to install BLE. So the BLE Bluetooth range is communication is 100 meters. So whenever we have an application of that shopping mall, Ratnadi, Spencer's, or any shopping mall, once we enter into the location, so we'll get the roadmap. What roadmap we have? In the rack 1, we have food items. In the rack 2, we have cosmetics. In the rack 3, we have groceries. In the rack 4, we have clothing. And in the floor 1, floor 2, floor 3, we have like this. So this roadmap, we used to get it on the mobile phone. And if we want to load our own list directly, it will give one by one to pick it up. That advancement we have made using this system. This was for the Germany shopping mall, not for Indians. Okay. So whether India has this kind of technology or not, I didn't see anywhere nowadays so far. So if we can find it out, it is well and good for us. Hope it is clear for everyone. So far, your understanding? Yes. So if you have any questions, please let me know. So are you feeling interesting learning about embedded systems IoT? So far journey. Adipali good no sir. Someone is typing yes sir and everyone is typing yes sir. Right? Sunil, you are also looking at me. Very smart guy. So overview of today's topic is completely related to cloud computing. IoT application as a cloud computing. So there are three service models in the cloud computing that are infrastructure as a service, platform as a service, software as a service. And we have understood how the cloud computing we are going to use in water quality management system. Okay, using any cloud provider like AWS, GCP, Google Cloud or Azure Cloud to control our hardware devices. The next thing is coming to IoT applications. So IoT applications in our real life based on the education, food, pharmacy, management, retail, logistics. So these are the major applications in our real life. So taking the particular example, okay, in healthcare, education, or in retail, or in management, taking the real life examples, we have understood IoT applications and the drastic growth of IoT applications from 2008 to 2020 so far. That's all. Venkateshwarlu. Yeah, yeah. So, so morning I start at 8 a.m. to the office. Okay. I'll drop my son in the school. He'll go to school. Then I'll go to office, driving around 70 kilometers up and 70 kilometers down, and coming back to home by 6:40, 6:45. Okay. And getting a fresh up, having a cup of tea with two biscuits, and starting your class and having my dinner, going to bed. That's all is my routine. Okay. And meanwhile, I manage the things. And if I put a leave, it is a leave complete. It is completely offline. I know to even touch my phone also. If any office call, even any personal call also. If I get any personal call, I'll get it from my parents. That's it. Yeah. Everyone has to be great like us, not me. Okay. More than me, there are very great people. I need to be in a forward step for them. Tomorrow topic name, we will have practical interaction. Okay. And next thing about the topic, I need to set the schedule or syllabus and I'll update you. Some part of today's topic. Okay. Venkateshwarlu. Yes. Next class. Tomorrow we don't have class, but next class. Got it, Sunny? Still you are in a school. So Blackbucks team will post attendance link. And I want to give you a small assignment. So everyone build a IoT application using ESP Node MCU. ESP8266 Node MCU. Okay. And using this Node MCU, yeah, I'm repeating, Venkateshwar. Using this ESP8266 Node MCU, connect to a sensor, read the sensor value on the IoT application. Like Blink app or ThinkSpeak. I'll write it on the screen here. Assignment. Sensor or actuator. Sensor means like temperature sensor, humidity sensor, pH sensor, smoke sensor, carbon dioxide sensor, or methane sensor, or any kind of sensor. Or actuators like RFID, fingerprint, face recognition. Okay, actuators. So taking these interfaces, publish data to Blink app or ThinkSpeak. Like that. Blink app can be used on mobile phone as an iOS application or Android application, or you can use as a web application also. But ThinkSpeak is a web application which is developed by MATLAB, and you can go in detail. This is optional. Okay. Reading this raw data from sensors, perform analytics using MAT. Is everyone able to follow the assignment? Venkateshwarlu, Spandana, you are able to follow the this assignment?